Hello YouTube, hope you had a fantastic week. The episode this week is a beast. We dive into Transducers, which is an advanced function composition subject where we take reducers and feed them into other reducers. It's a reducer. It is a long episode, but it's also a very tricky subject to wrap your head around, so it requires a little bit of... The show this week is sponsored by .tech, the tech TLD. .tech is a TLD used by CES, and it's in general a good TLD to use if you're running a tech company or if you're doing some kind of programming project, or like it's a very useful TLD for everything in tech. I personally use semicolons.tech to redirect to my semicolons video whenever somebody asks on a comment, why don't you use semicolons? Use the link in the episode description when you get your .tech domain, because that will apply a coupon code at checkout which gives you 90% off. Woo! .tech, thank you so much for sponsoring the show. Before we jump to the recording of this week's live show, I will, as usual, give you a little bit of an overview of what we talked about. You can also find some time codes in the episode description, so where you can jump to the relevant parts that I'm talking about. Me and Sean, who by the way is a senior architect and a very frequent member of the Fun Forum and like an amazingly smart guy, we start out by talking about what the why of transducers and then move on to a little bit of what they are. It turns out that transducers is this technique where imagine that you have a huge array and this array has a lot of filters and maps and other kinds of processing going on in it, and you it's just going slow. So transducers is a technique to take all those maps and filters and convert them into reducers, and then combine all those reducers into one mega reducer, which can process each item in one fell swoop, making the array processing much faster. So it's a functional optimization technique where you do pretty funky function composition, to say the least. And it's also like a wonderful mind bender that makes you understand the concept of a reducer much better on a fundamental level. So Sean starts me off by making me re-implement map using a reducer, like implementing map as a reducer. After we have that map as a reducer, we remove the array knowledge out of that reducer. So the reducer is now unaware of what an array is. Then I have a pretty cool insight about what a reducer actually is and understand that at a better fundamental level. And then after that, we tie all the parts together and show how to do the actual transducing. This is a mega video, but if you are interested in finally getting what a transducer is, then this is the video for you. Alright, if you're finally ready to learn transducers, here we go. Yeah, what are transducers and why do they exist?
Okay, so the value proposition of transducers is probably the easiest place to start. So the value prop is the following. So if I had a stream and I chained a bunch of map calls on it, that's fine for the performance of a stream.
Yeah.
I could run 1 million elements through that stream and it would be just peachy.
Sure.
If I had an array that had 1 million elements and I chained a whole bunch of map calls, it would cause a bunch of problems. Because if I had an array of 1 million elements and I have 7 map calls, I now have 7 million operations.
Sure, and then like each item is we're gonna wait for each step, and then we're gonna wait for each step and each step. Yeah.
Yep. So now, the way to get out of that with map is to compose those functions together. So if you had just made a composition or a pipe of those 7 functions and put them in one map call instead of 7 chained map calls, at that point, you've gone from 7 million operations to 1 million operations.
So let's actually try to see if we can map do something like this. I'm just gonna write Sean1.js. And let's say that we have some kind of stream, silence ESLint, and then like we have all of these map calls. Like we're gonna call map do thing 1, do thing 2, do thing 3. And this is fine in the map case, in the stream case, because like we are processing every item as it comes in anyway. But for an array, and let's say that this is 400,000 items, that would mean that each operation here will have to be done like there will be like 400,000 times 3. Is that correctly understood? Then in order to like get these 400 these 1.2 million operations down to 400 again, we would compose these functions into one. So if we use something like, God, I hate IntelliSense. IntelliSense is the most overrated thing. Is this how you do it? I'm just playing around here.
That's right.
Yeah. Then I would just take this thing here. Why did I copy paste all that? That's and I could just do one map. So for the people of you like those of you that don't know how compose works, it basically this is a common functional programming thing that takes 3 functions and returns a new function that just takes an item and pushes it through all of the 3 functions in one fell swoop. So doing it this way means that we just do 400,000 operations instead of 1.2 million. Did I get that right, Sean?
Mm-hmm. You did. That is math. Okay, so now you have solved the map problem, but what happens if you have a bunch of maps and filters chained together? You can't really. So if it looked like map, filter, map, filter, filter, map.
Yeah, so it was filter and maybe like some reduce here as well.
Mm-hmm.
Does that work for your example? Yeah.
Oh, yes.
Yeah.
You can no longer actually compose that stuff together.
Yeah. Yeah, exactly. So this strategy would not work.
Right. So this is where transducers come in. So the concept of transducers is the same form of composition, but for reduce.
Oh, okay. So we would have like something like oh yeah, we can't have this though. I'm making a bad example here, but like it's gonna be reduce. Like I don't know. This is not helping anyone at the moment. But like I'm just trying to visualize it in my head. Yeah. So if we have a case like this, then we can transduce it. And for and for the people that don't haven't done too much functional programming, reduce is kind of like the common denominator, like the least common denominators, so to speak, of map filter and things. It allows us to do any kind of operation really on a reducible object. So it allows us to reduce an array to anything and do anything on it, really. Reduce would allow us to implement map or implement filter or whatever we want.
Yep, absolutely. And I would suggest that would probably be a good place to start. So to get a better handle on how we would get a whole bunch of map and filter and reduce chains into one transduction.
Transduction. Let's just like revel in that word. That's a very good. That is so good.
Then I would think that starting by implementing map in terms of reduce would be a good place to go.
Okay, cool. Sent you a Visual Studio Code invitation link so that you can jump in and highlight segments as we go.
Ooh.
While Sean is doing that, I'm going to do a similar thing for the chat. So if you want to highlight a line, you can do that. Somebody in the chat that knows how to do that will probably point that out, such as Clark.io, who has written the extension. Ta-da! So this now Clark.io has highlighted this line here, and it's a good question if you want to ask something about a specific line. Doop, doop, doop. So where do you want me to begin?
Yeah, I think starting by implementing map in terms of reduce is exactly where we should.
Okay. So what we want is to implement map using reduce. So let's say that we have a stream here. No, like we have an array. And let's say that, thinking about like an example of something like something that you would want to map. Let's just say that we have customers. No, we have dragons. We also have dragons. And then they have names, and it has a let's call it Fluffykins. And then they have a size 1. Wargle size 3. And then we want to map the dragons. Dragon, and let's say that we have if the dragon has a size that is bigger than 1, we are going to return dragon.name Great. Otherwise, we are going to return the tiny. See what this yields us. Start Quokka. Yes. Boom. Yeah, cool. We get Fluffykins the Tiny and Wargle the Great.
Very cool.
Dum 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 dum. All right, awesome. Fluffykins, the foreplay asks, Fluffykins is not great. No, Fluffykins is a very tiny dragon that breathes fire. If there's anything that this channel has taught you, it's that. All right, so our assignment here is to re-implement map using reduce. So let's have a look at this. Dragons dot reduce, and this is so the second argument to reduce is an empty array, because that's what we're starting to work with. And let's see if I remember this from memory. Like the first argument to reduce is the previous item, and the second one is the current item. Am I correct in that? I think so.
Yeah, I would consider the first argument not necessarily the previous, but the collection. It will be the thing that you are building.
Yeah, right. Yeah, that's true. So let's call it like the. Yeah, it's kind of like the thing that we are aggregating, or like the target. I keep like trying to find like a good general name for it. Like Prev is like my best name, but like building. I'm gonna call it target today. Like it's one of my many generic names for the so when we begin, like the first loop of, why is t not defined? What is the expression expected? Oh, it's because we don't actually have anything in the reduce function yet. It's not it's not running. So I want to keep this running as we talk. So target is on the first iteration of reduce, it's going to be the empty array, and then on the next iteration it's going to be undefined because we're not returning anything from reduce. So I'm gonna return, and then on the second iteration we see that it's an empty array again. Let's also inspect the current one to see that what is happening, and that's on the first iteration we see that it's Fluffykins, and on the second iteration we see that it's Wargle. So now we want to implement map, and then we want to run cur through a transform function, a callback function, before we put it into target. So I'm gonna wrap this into a function, and we're gonna call that function map. I think we can do that. I'm gonna call it the generic array here, and we are going to call the second argument callback. We'll probably like talk about a better name for that later maybe, but we'll see. And so we have the array here. Dragons is not gonna work, or we want the array. Let me actually call this on our dragons array, and then paste in this same callback here, the same code as the callback. See what this gives us. Let's scroll down a little bit.
Cool, and you've got an empty array back.
Yeah, exactly. If you look over here, we see that it's an empty array. Yeah, because and that makes sense because we see here on line 16 that on the second iteration we are returning an empty array. So it's working as expected with the code we have. But now we want to what happens when we call back here with our current iteration on our cur. Then we have Fluffykins the Tiny and Wargle do great on each one. Then we want to take target here and concat it with our callback.
Very good.
Did that work? Wow, that worked. All right, we now have an implementation of this. Can actually remove these curly brackets here.
And just before you do,
yeah,
I would suggest, for the sake of the next step, making those two different lines.
Which one? Oh, okay. Like, you mean like this?
Yep. So what I am going to suggest is that that reduce function that you've written.
Yeah.
There are two steps inside that reduce function. The first step is actually doing the thing that you intend to do, and then the second step is combining your value with the rest of the accumulator.
Yeah, so this is the actual transformation on line 15. And the second part is here on line 16, where we are combining them together.
So now, what if we made that second step part of a higher order function?
All right.
So instead of calling target concat, because that means that we're assuming that target is always an array, what if we had a catenate function which was provided before the reducer?
Ooh, okay. I think I understand what you're getting at. I'm gonna remove this and comment out this old map function, and put it in the put it down here. Get rid of it so that we have all the code that we want on screen. Oh my god, shit! I moved the code a little bit. Yeah, all the code is on screen. Fantastic. Okay, so what we're getting at here is that we want to get this part here and move this into like some higher ordery thing, because we want to be able to do like a generic map that doesn't because the problem here that is a map, our map that we have implemented here, is aware of that array has a concat method.
Yep.
So we want to create a map that is unaware of that can do this for any kind of object.
So I think the next step that would make the most sense, not that it will make sense necessarily, but let's try baking the code back into the reduce. And what if we made a function called getDragonTitle, which was a reduce function, except that it had the catenate provided before the reduce function.
Oh, okay. So let's say let's do exactly that. Get dragon name. And say that we call this, God, I'm gonna call this putter, this function name. And then let's say here, get dragon name.
So it still needs to return a reduce.
Oh, it's a need. Okay. So needs to return a reduce. So it's sort of like this function, but it needs to perhaps do. No, wait. Jesus Christ, this is difficult to keep in my head. Because I want to break out.
What if we just start here and re-implement that, but dragon specifically?
Okay. So let's, instead of passing in the callback here, we're going to, I'm going to comment out the map function here. Maybe not. I'm going to just copy it. And we want to make this dragon specific. So I'm going to grab this dragon specific code here. Or maybe we can just call this, can we, let's extract this, I want to extract this out. See, and we're gonna call this get dragon name. And we're gonna pass that into there, but we need to have this a little bit higher, otherwise it won't work. And I'm gonna reduce the size a little bit so that we see more. Okay, so now we want to make this here on line level map dragon, maybe.
We don't even need the map right now. We just need the reducer, the function that you pass into the reduce.
Like, you mean this? Oh, like
just that, yeah.
Okay. So I'm gonna call this something we are building, because I have a hard time naming this so far.
Yep.
Is this still the signature that we want? We have array and callback.
It is not.
No.
So what we want is a concept of concatenating or catenating or joining. Right? We're building a higher order function where we're basically taking this and we're making it generic.
Where we're taking this and making it generic.
Oh, the return statement on line 14.
Oh, okay. All right, so we want to then Jesus Christ, this is hard. But we need to get this. We need to get this in somehow. So let's just call this like processor. Or like let's go back to calling it putter. And we have, let's say that we call it const putter, and putter takes the target, and we're gonna call this array putter. And this is going to take a target and a processed item. Don't judge me on my names. They're like naming is hard. Okay, So array putter, and then we're gonna call array putter with the processed item. No, the processed item is the second one, and the target. So in order to create this, we would then call, let's say,
You're going to hit one fun error, and that is line 12.
12.
It's still called
Oh
process.
yeah, I see that. That actually, Visual Studio actually helped me with that. Thank you, Antipixelated. Bloop. So, let's see now. I am going to take this map here, and I'm gonna make use of something we are building. And I'm going to remove this here and call it with the putter, the array putter. Jesus, did that work? Let's see. I'm calling that map 2. See if what happens if I call this with map 2 dragons dot and get dragon name. Undefined is not a function. What is that?
You aren't returning the arrow. Line 15.
Oh, I see. Okay, now callback is not defined. That makes a lot of sense.
It does, and you don't want to put it in there. That will cause heartache. For right this second, just hard code the dragon title, get dragon name in there, and we'll prove that it works, and then we'll fix it.
Okay, so get dragon name, cur. Okay, so now we have a we're somewhat on the way to a something.
Funny enough, we are pretty much there. You don't know it, but we are. So
yeah, we're not. Clock.io points out here that we are not using putter. Not the Antipixelated points that out.
Just change that name. So line 14.
Oh.
Use that on line 17.
Oh, yeah. I'm actually, I was fooled by my extraction over here. So let's. There we go. Okay. Yeah.
Okay. So now there's a fun little bit of learning here, and that is that the putter, the concatenator, the joiner, however you want to think of it, is itself a reducer. Right? Because it's taking an accumulator and it's taking whatever your value is.
What do you say? Like the putter is a reducer. So, oh, so it has the same. You mean that it has the same signature as?
It does.
Oh, so this is, yeah, okay. So this is kind of like, also like, I see.
So now you could have a string putter instead of an array putter, where all you're doing is joining strings together.
Oh, so let's say that we do this, const string putter. And we take a target and a cur, and we would take target, which is going to be a string, and we're gonna do join cur, and we're going to join by beep, comma, and then we'll use the string putter here instead. Whoops. Join is not.
Um,
No, which makes sense because it's an array, so we have to begin with a string. Okay, I expected that to work though. Is target what? Hang.
Arrays have the join method. I think string just uses concat.
Why do I think it's join? No, wait. Yeah. No, I have to check this for myself. Let's see here. Just so I understand what the hell I'm doing. What does it give me? Concat. What if we join? Yeah, this is what I was going for.
Yep.
So why does this not? I expected this to work.
Because your target right now is a string.
Yeah. Which, and yeah. Okay. Right, I'm mixing them up in my head. Right. So the string we want to concat. You can't use join because we don't have access to the.
Mm-hmm.
Okay, so we have an array. Oh god.
So
God, why am I breaking up this in my head? Why am I getting stuck? The string putter takes in 2 arguments. Current is going to be the string, and target is going to be that's the thing that we are constructing.
Yep. And our expectation for the string splitter or the string builder is that it takes a string, and ultimately you will get a string back.
Yeah. So both we expect. I expect these to both be strings, but this is an array, so that's a bug.
It should be a string right now.
Yeah.
So you should, instead of saying target.concat current, you should just be able to say target plus current and sort of prove that they're strings.
Yeah. Okay, so we get Fluffkins the shiny and Wargol the great. Yeah, so they. It seems to me that they are.
So in map 2, the rightish thing should be coming out.
No, hang on. I see. Hang on. Something we are building. Yeah, the rightish strings should be coming out. Oh, so it does.
And there it is on line 35.
I still don't understand why join didn't work. Why does this? Oh, okay. Yeah. Now I get it, because we are. Yeah, because reduce works by like returning the constructed object, and then we are pending on the structured object. Like this, join does work on the whole array object at the same time, so I'm confusing them in my head. So this is not really at all relevant.
Right.
Get it.
That is almost it.
Yeah.
To be totally honest, there are 2 more steps. Step 1, you can now chain. If you made, if we talked about math and we just talked about like adding 1 and then tripling, we could make both of those in the same sort of way that we've made something we're building.
Can we get, like, before we proceed, perhaps we could get a better name on something we are building, because it seems like an apt time to name this. You probably have a good idea, Sean, but I think that perhaps, like, audience, what do you think would be a good name for this? For the thing that it's something we are building that takes the putter and returns like the reducer function. Like perhaps like Like Dork suggests transducer. Or would transduce be good? Clarko says mapducer. Najgor says, for me, this function should have the name headcracker.
Yes, it should.
Robert Tables, good Monday morning to you too. You're just joining us like in the naming an extremely hard to name function. Nout says that the array putter should call array reducer. That's actually a good point. Yeah, because this is a reducer. Like this is what a reducer is. It takes a target and a current. So let's fix that actually. Call it array reducer. And call this string. Yeah, it kind of like, I like this because it kind of like entrenches my understanding of reducers. It like a reduce function. The reduce function is something that takes a reducer, and a reducer is a function that takes a target that we're building and a current item.
So now you will be confused to note that headcracker is basically your transducer, or your first transducer.
Oh, so this is I guess that this is then a what is it then? A dragon transducer?
Yeah. So there's a little more to it, because this pattern becomes very, very familiar, right? We're mapping, and then we are, and then we're sending that mapped value through a reducer. So anytime we're doing that and sort of baking the code deeper into the function, it might be a good time to make another higher order function.
Yeah.
So
yeah, is this like, why are we calling this a dragon transducer? Because it's still like just returning a reducer.
Mm-hmm.
So like, why are we not calling this make dragon reducer?
Sure.
All right.
So now we probably want to make one level higher.
All right.
So,
yeah. Okay, I get it. We want to extract that get dragon name. Clark Arrow says, "I'm sorry, but I'm a bit confused still. Could you all step through the flow to explain things?" We're going to. Perhaps we actually should pause and take stock of where we are actually. Before we proceed. So I'm gonna get rid of. We're actually gonna reduce the font size a little bit to the chagrin of our mobile viewers. So let's begin here. We have a dragons array, and we are a little later here. We are mapping over it. So we're getting like Fluffykins the Tiny and Wargle the Great. We have this getDragonName function that, depending on the dragon size, it returns a dragon name. And what we first did, we started by re-implementing array.map here using array reduce. We made use of that, and we proved here that this worked. Then we we broke out and started generalizing this little part here. We tried to make a sort of a map that is unaware of the the concept of an array. So like the problem with map is that it's aware of an array. We want to make a generic version of that. And that is what we ended up with here. We have like a map2. We're like just so that we can have it side by side here. And that takes that takes an array and reduces it, and then it calls this function that we have created here that makes a reducer function for reduce here based on this string reducer here. Because we know that we want, hang on, we'll actually revert back to the array reducer for a bit, because otherwise our results are not going to be correct. So this makes a dragon reducer based on the array reducer, because we know that this is an array here that we are working with. And that is basically where we are. The make dragon reducer takes this array reducer as a putter. Oh, by the way, putter, we discovered that is actually a reducer. Putter puts things into things. And this returns a reducer that is aware of the get dragon name function, processes that, and then passes it into the reducer. So it basically adds this thing here, and this is where we are now.
Yeah. Does that make sense?
Yeah. Like Ronin says, do you have a drawing tool you can use, like a whiteboard of sorts? Might help with the flow. Yeah, we might do that when we have everything in place. That's a really good idea. We'll try to do some drawings to try to get people to. But for now, I think that I want to proceed with extracting this get dragon name.
So now we probably want to make a more general function, or slightly more general function, with that transform on the outside of this.
Yeah. So we're gonna call this transform.
And again, for sake of heartbreak, I would probably make this a function that wraps your function.
Halt, what? Oh, like you make what function wrap function?
We will spoil the surprise, but if I called it map and it took a transform and then it took a reducer and then it returned whatever.
Oh yeah, like a currying-ish thing.
Yep.
Okay.
Remember when I said to hold on to that knowledge?
All right. So, right. So transform should be a. But I'm not sure that helps me. I understand like this concept, but like I'm still too confused to get it. I think I need to fall into this mistake on my own.
Okay.
Because the way I'm thinking about it right now is that you see that here we have an error here that like a problem that callback, we're not actually using callback here. Because make dragon reducer is like already aware of get dragon name.
Yep.
So like what I kind of want to do, like I'm gonna go naively here and just pass the callback on to the make dragon reducer here, and pass it down here, and then I'm gonna call the transform instead here.
Mm-hmm.
Yep. And see, like, and now this is incorrectly renamed because like this now takes it takes anything, it doesn't know anything about dragons. So I'm just gonna rename it make reducer.
Sure.
From transform, or yeah, something like that. And what do we get now? We have like, to me, this, okay, so it works.
Mm-hmm.
And what is this? Have we implemented transduce here, or like?
We were already there before you added the second argument.
Oh.
So before it had transform, it was already a transducer, but you are absolutely right to want to pull the transform out. So...
Oh, so we could... Oh, hang on. So... okay, so I think I get what you are... Are you saying that this is sort of unnecessary somehow? No, I need more help, I think.
Okay, so I think that line 24... line 24 and 26 and the return statement are probably unnecessary at this point in time.
Line 24. Unnecessary. How? Like, that's a... But line 24 is like the function constructor or function signature.
Right. So ultimately, where we would want to get to is where we can compose a bunch of, and my mouse disappeared for no reason, from my own screen, go Windows. We want to be able to compose a bunch of these together, the same way that we would compose a bunch of map functions together.
Oh, okay.
And that's why having the transform second is going to make it harder than turning it into the curried thing, because ultimately we don't necessarily care about this part yet. We want to build the map function.
Okay, so I kind of, let's say that, okay, so I want something that works like this, if I'm interpreting you right. So, God, I need to remove this. Clark, okay, somebody did, thanks. Make me use transform and const dragon wait, yeah, dragon reducer-ish. See if I get this right. And so I want something that allows me to do this.
You're pretty close, actually. Now, what if...
And so yeah, continue yours.
What if we built that using map, the same way that you would build like a curried map function? So
yeah.
What if, I guess, what if we had an API that was nicer, like except that we already have the get dragon name, so and then we could just put the actual the code in there, and then out the other side would come the function that is expecting the reducer.
Okay. So the function that is expecting the reducer. So basically, we want to inverse these arguments. So let's say I'm gonna copy this by size so to remember where we were, and then we will take the transform and then the reducer, and then we would return another function. That will no, like this, which will do the actual return. So we're gonna call this, God, what are we gonna call this? Abstract abstractors on. Okay, like right. So now we have like a variant of this, but it's a little bit curried. So then we can call abstractors on with our transform, and I'm gonna like, just to track this through the entire thing, I'm gonna stop using the term callback and call it transform. So now, does this, are we working? No, it's returning a lambda here because we're like returning a series of functions.
So what it wants now is a reducer that tells you how to tie the loose ends together. So what gets returned is that reducer. So on line 35, we probably want to call it a second time with your array. It's no longer called array putter, array reducer.
Oh, okay. So yeah. So because right now map does not know, like map, we have not introduced knowledge here into map how to actually do the the array reduction. So that therefore we need to like actually pass it in the array reducer, and we do that by this.
That's right.
All right, and now it works. Okay, that makes sense. But why was it important to curry this in this curry partial application doing this?
Ultimately, it would become handy in your system if you do have the problems where transducers help. If I take a stab at renaming abstractorson, and it's pretty abstract, and I call it map, I could say map or transducer map item, and then I could item dot name it. And of course, that's going to return a function that wants a reducer. And then I can have maybe another one, not mape. I think it's that. So at this point, I'm building a bunch of functions that expect reducers. But there are also a bunch of functions that return reducers.
Oh, yeah, this map. What do you mean that they expect reducers? Like we have used reduce to build these functions.
Yep. So if I were to make an abstractorson, that was called map, that took a transform and then returned this function. So let's call this transduce. Then it's expecting this reducer.
Ah.
So now...
Oh, so the reducer, which is like, say, the array reducer.
Yeah.
Oh, okay. So we can... So we could actually, let's say then const, let's see if I get this right, map3, call, okay, I have to rename this into map1, otherwise wow, we have a lot of conflicting names here, but map3, we're calling like your new map here with a transform, which is our like it's this on the GetDragon name, and then we call this with the reducer, which is the array reducer.
Yep, but they're two separate function calls.
Well, hang on. So map, yeah, so map is going to be called with, yeah, because map will take this and then reducer. Okay, cool, fine. And then let's see. Oh, look, I have to verify that map3 works here. Nah, it doesn't yet.
And map3. So you now have target and current. So it wants to be put, your map3 right now wants to be put inside of an array reduce.
Sorry, take that again.
Actually, it doesn't.
Huh. Like, and Ronin says it can very quickly end up being clever code that people don't understand. I completely get the feeling. It can offer a lot of power and extensibility, but requires some external effort to understand. Hang on, and this was something that Varkin said. Why does this feel like a trailhead that leads engineers down the path of unnecessary levels of abstraction? This is definitely something that, like, I also get this feeling from this code. We are definitely going to address that, like a little bit once we are in this space. I think that transducers is actually one of the things that does offer value. But which we alluded to it a little bit in the beginning of this of the show, and we're going to reiterate it in a little while. So don't dismiss it quite yet. Okay, so where were we? So right now, map3, we have the problem here that it's still returning the it's returning the full items. It doesn't seem to make use of GetDragon name yet.
You are right, because if you have a look at what map is returning.
Yeah. So it's returning, it's calling reducer with the processed item. No, wait, hang on. So let's see. Map is returning a transduce function, which accepts to be called with a reducer, which we do here.
Yep.
And then map3 is going to return a function that, oh, it's returning the reducer. It's returning the reducer.
Right.
So this is not yet complete. We need to pass this to like a generic reduce, like x dot reduce No, maybe this doesn't quite work.
At this point, I would argue that you can just pop that straight into an array reduce, and no extra function wrapper would be needed.
Okay, so let's say that we just do dragons dot reduce map3. No shit. Yeah, like this, but we will also need an initial array.
That's right.
Okay, cool.
So now the last piece is that we wanted to get to compose the whole time. And the composition comes in when you realize that array reducer,
Yeah.
instead of passing in array reducer on line 44, you could pass in another transducer.
Another transducer. Oh, okay.
So if you
So this is where the chaining comes in.
Exactly.
Okay, okay.
Yes, Plateris, it is a reducer. It's more like compose for reducers.
All right, this is so hard. All right, but it's fine. We're breathing. Okay. Functional programming is always like very complicated very hard until you get it, and then it's simple. Right. Okay. So we can pass another reducer into. Yeah. Okay. Okay, hang on. I'm gonna like get rid of our old maps here for a while.
Yep.
And see just a little bit. I'm gonna move these out. Gonna call these. Gonna comment them out. Get them out of mind for a little bit because they're not. And this name here is a little bit confusing to me.
Mm-hmm.
Like map, I'm gonna call this map for map producer. No, that's probably bad.
What if you don't call them both in line, and you only build up to the map?
Like this. No? Was it?
No,
that was not what we're looking for. Not call them both in line, but build up to the map.
So, I mean, like stopping at the first function call and giving that a meaningful name.
Oh, okay, so this is something that waits for a reducer. So, what is something that waits for a reducer?
But it's also a domain-specific thing.
So is it a dragon transducer?
It is. It is specifically a dragon name transducer.
Dragon name transducer. Okay, that sort of makes sense, but I'm getting rid of that.
Then you don't need that yet.
Okay. So, and I guess I need to array. What was that again?
Reducer.
Array reducer. Okay. Right, and now we are like, this is still working.
So now let's try adding an uppercase transducer.
I'm gonna get rid of this code. An uppercase transducer. No, sorry.
Yep.
Okay. Oh, you actually had the code for that. Sorry. There we go.
apparently a typo. So let me fix the typo so that it doesn't explode.
Okay. And now we're gonna do an uppercase transducer. Okay, cool. And it's no, exactly. I actually have to use the bloody function.
Yep.
And that gave us a bunch of functions. Why?
Dragons reduce case transducer, array reducer. Because
No, because because we are calling map on it. Like it should be just this.
Yeah, that makes a little more sense.
Yeah, but we also hang on, uppercase name. These are actually not. It expects a dragon.
Right.
And the dragon has a name. There we go.
Right. So now, instead of having a dragon and a dragon expect a name, what we're going to do in the last step is we're going to compose those.
Oh, by the way, Ronin points out that it might be cool to try some basic performance analysis if we have the time. We might try to do this on like a billion items and see, like, to actually show the benefit later. Yep. Because that's probably a good idea. Oh, sorry for interrupting on that.
So we want to get back into composing these just like Ramda compose.
Okay.
Right? Or Ramda pipe.
Yeah.
So what we're going to do is if you change that back to name instead of dragon name, it's going to crash right now, but it will stop crashing in a second. And then you'll need to change the argument as well. Cool. So now, what we're going to do is call dragon name transducer first inside the reduce.
Call dragon name transducer inside of the reduce. Okay, sure.
And what we're going to do is we're going to pass it uppercase transducer.
Oh. Right. It still doesn't work. Like
it
no
doesn't?
Or yes, it does. Oh yeah, it does. It does. It actually does. It gets the proper dragon name. Yeah, hang on. Like this becomes a little bit. Let's actually these dragon names. We're gonna call this get dragon title. As in, like, it's royal title. Otherwise, it becomes confusing with the name. That is why this confused me. Okay, so right now, it actually gives us Fluffykins the Tiny and Wargle Great the title of the dragon, and it uppercases it. And it has done this in one function because we have, like, passed them through each other. Wow. That is fucking mind-bending. But I think I kind of get it. I really think that drawing it out would maybe help for some.
Yep, it is a little tricky, and starting with as much as I hate to say it, starting with math is usually a little bit easier.
Yeah.
Just because I guess it's easier to keep, like, I'm adding or I'm subtracting as my final reducer in mind.
Yeah.
But in this case, you can see that if you look at line 35, line 35 is step 1 of what the reducer is doing. And line 36 is step 2. And then we... my mouse has completely disappeared. Sweet. So I'm going to guess. Hooray! line 36 is step 2.
Yeah.
So we've pulled that out into this reducer.
Yep.
And then we've pulled the transform out into map, because map deals in transformations.
Yeah.
So we could also write a transducer that filters the same way that we've written map.
Okay.
All we need to do is determine whether we're going to return the current target or we're going to return whatever this reducer does.
Wait, return the current target or whether or not the... No, you have to like just repeat that sentence again. We want to return a, like, if we're gonna write like a... First of all, I wanna, like this, it's complete, it's super confusing to me that we name this map.
Okay.
Because map, it doesn't actually map. It returns like this doesn't, it doesn't feel like the map signature to me. Like, because
right.
If it did, I would be able to pass in an array here, but this is kind of like it actually returned like some kind of weird generic map. So I would call this like make map transducer instead.
Yep.
In order for me to like grab what it is that.
Yep. So in a bunch of libraries, you will either see that called t.map or you will see it called tmap.
Tmap would sort of make sense to me. I like I like tmap because that means like transduced map thing.
Mm-hmm.
Is it like this?
Sure. And then Yep, exactly like that. So now, if we made a T filter...
Right, now we're getting into this. Yeah. Then...
A filter's only job
is to... Okay, so... this is not a transform, but it's like a... what do we call it? Conditional?
Predicate.
Predicate. And if the predicate returns true, we will add it. Okay, hang on. We will. If the predicate is true, we're going to use the reducer. Otherwise, we are just going to return the target.
Yeah, you got it.
All right, and then let's see that we create a. See if I get this. We are going to call this a size filter. No, uppercase transducer. Hang on. Let's start with the filter. Const is big. Is great. And dragon. Or you're gonna come like yeah, let's just call it. And dragon has this size. The dragon dot size is above 1. Const, and then we're gonna do like is big transducer. It's big filter. Yeah. And we're gonna call t filter dot is great. And then we are going to filter out, see what this is. I'm gonna take the is big filter and call like this. This is, and our parents. Did this work? No, I'm missing one parents. Goddamn. This requires a little bit of I'm doing some mistake here.
Mm-hmm.
Okay, so dragon. Why is this not working?
Because you're at the last step, honestly. So the last step, we are taking our dragons,
Yeah.
and then we are getting their name, and then we are casting the name to uppercase, and then we're filtering the name based on whether or not it has a big size.
Oh, okay. So it's again the order of this throws me off. So it's actually gonna be this order. Wait, what? I thought this was gonna be correct, but it wasn't.
I think you swapped the spacing of the dragon name at the same time you swapped
Okay,
the filter.
let's see if I can do this again.
Other way.
What?
So if you move the dragon name
Yeah.
up to line 61,
Yeah.
now processed is not okay. Then you've got two errors.
Oh, okay.
Where is the the errors on line 44?
Process is not defined. Oh, okay. Yeah. Okay, yeah, because we're not processing anything in filter. The error actually makes perfect sense. So in the case of filter, we are just like either like we don't care about the output of the predicate.
Yep, that's right.
We're not using that. So right. Okay, cool. So it passes it through the isbig filter reducer, then the dragon name reducer, and then the uppercase intruder, and now we only get Wargle the Great. Now Fluffykins is filtered out because Fluffykins isn't great. All right, so in order for this to this is kind of ugly without the compose. So let's write a simple compose function. Does anybody have like a compose fins? So compose is functional programming thing. Like it's where it's to slap a number of functions together, basically to do this without like this horrible hierarchy thing. So I think it's kind of fun to implement this in procedural programming, just because we can. Last result. And then for const fn of fins, then last result equals hang on, return val. No, it's better to do this. And then do we call the function with either the last result if we have it, or the value from the function, and then we return the last result. Bonk. And now let's do this. See, tie this all together. Dragons dot reduce, and we're gonna compose And it's gonna be in the inverse order, I think. And I think we're gonna need and then we need to call this with the array reducer. Something like that.
Invalid syntax.
Oh no. Where is my syntax invalid? Let's look at the output here. Where's the output? See. No.
You are missing a brace on compose.
Ah, see it. Whoops. Sorry, everyone. There we go. And we have identical results.
And the whole thing works?
Yep. I'm very happy that I wrote compose correctly on one attempt.
I would not have been able to do that imperatively off the top of my head.
All right, so compose is generally not something that you need to implement yourself. It's available in Ramda and any functional library.
So, now, practicality.
Yes, yeah, exactly. Like, was this a completely insane abstractionality thingy-bob that we did just because we wanted to feel smart, or does this actually have like some kind of applicability?
The answer.
But either way, like this is actually a good question for play. Why is the order reversed in compose? It just happens that way naturally, really. It's because of, like, you see that the order, like, just because of the order of things here, like, because we have this thing that we loop through, the order just ends up being inversed. Could we say that? Like, it's just like the natural thing that... Is that a fair assumption? Like, there is actually, like, I'm not a fan of compose. I like pipe because it does the inverse reverse. Pipe is also a common function which does the inverted thing. See, it's yesterday I do it correctly here, yeah, and then we change to the uppercase transducers. So pipe is more natural, feels much more natural to me, honestly. Fortiside says, why return function and not arrow function on line 59? There's absolutely no reason. We can absolutely do this with arrow function. It's just that I feel like I often like to use functions because it kind of like gives me more readability and sensibility. But we can do that. Let's see. Let's just do womp, womp, and then we do womp like that. And it broke. Shit. No, because now I have one brace too much. So now we have that. Kind of cool. A lot of these can be insanely small when we start over exploiting arrow functions. Also remove that. Can we do remove that with dot or dot? No, that would be.
No, it has the sad.
Okay, cool.
So in terms of practicality, foreplay, the order of transducer execution. So it comes from is big filter, yep, and then dragon name and then uppercase. That's right. Um, so in terms of practicality, there have been several projects that I've actually had to use this on. And the reason that I've had to use it is because, without giving away the details, there was a bunch, like a bunch of customer information. I had to build graphs, and it actually involved making a custom graphing library for this particular example, just because what they needed could not come out of a box without thousands of lines of code. Anyway, we were graphing over users, customers' data that might be like 100 records every week or more over the span of 6 months, I guess, to fit on a graph, where you had a whole bunch of analytics running. Like, if you see this piece of data hit this value 3 times in 4 months, then throw up this flag on the graph. So there were 20 of those running in practically real time.
Oh my god.
So I had everybody just write everything in terms of .map and .filter and .reduce, so that all of the functions were single unit testable things, especially because this was in a regulated space and we needed to like prove that everything worked and worked well. So that, as you might be able to guess, had a performance of like 3 minutes locking the browser while it calculated. Yeah. So instead of doing that, moving to transducers, and actually that wasn't the biggest save. The biggest save was not using the date library and just doing it with timestamps, but whatever.
I digress.
Going from something that might have been 18 chained map and filter and reduce calls to one of these per measurement, or at least per flag, I suppose, per measurement, had a huge impact.
Yeah, makes a lot of sense, like, because that is exactly what we talked about. And I find that when it comes to performance and functional programming, I find that whenever what's the use case of the more advanced stuff, it always tends to be processing of vulgar amounts of data. That is why, like, the first time I used MapReduce for, like, when I really had to use like the MapReduce technique, that was when I was writing a data processing pipeline at Spotify, which processed like 40 terabytes of data, and we wanted it to do it in a couple of minutes. So could we perhaps do a little bit of performance testing here? Because it seems like if we just had like because this is the fast version, right? This takes this reduces the dragons. Let's write the equivalent without, and let's take dragons, and we filter it with is big. Oh, hang on, where the hell are we? Is great. It's not gonna. We're gonna call it is big. It's great. Dragon transducer. So we filter it for it if it's great. Then we're gonna take the dragon name, map, get dragon title. Yeah. And again, that this is a wrong name, we're gonna call it dragon title transducer, because again, name is the property and dragon title is like the royal title. Volga the Great. And then we're gonna uppercase it. Uppercase transducer. And this should yield the same result. It didn't. No, because we're gonna uppercase name. Cool. And this is just really not uppercasing a name, it's just uppercasing. There we go. So now we have these same things. But let's say that we have a bigger dragons array. We're gonna let I equals 0, I plus plus. No, we're gonna perhaps, let's say probably 50,000 should be enough to see a difference, maybe. Yeah.
Just hoping.
I'll see. And then dragons dot let's concat. We're gonna concat in 50,000 fluffykins. No, dragons push. What am I doing here? Wait, why is this wrong? This seems... Oh, I have one parent too much. That's why. There we go. Yeah, clock AO, remove extra curly. Thanks. Let's see. So now dragons dot length. Yeah, it's now 50,000. Okay. Oh, great. I think that Quokka. Does anybody know how to do Quokka timers? I think that you could.
Is it a period?
Maybe. Oh yeah, cool. Oh, Quokka is so good. And so we have like the reduce here, and this is the manual one. So, oh, you need to do that. Oh no! The reduce one is slower. Why? Let's increase this to 500,000.
It might be your pipe.
Oh. Hang on. So the pipe. Oh yeah, because it does a reverse each time, perhaps.
Oh boy. And because on each function call it is running through the loop itself.
Oh, okay.
Slightly more here, let me see if I can if I can remember this live.
This is so cool.
Right. G F X G F X and then I'm not going to worry about identity. I'm just going to assume that we have that right, and then we're going to move that there and move that there, and add a comma. And it's still slower.
Shit! We just proved ourselves wrong. Oblivioner asked, will it be put on GitHub later? I tend to make just a gist. That's interesting. Like, this really should be faster. Like, this makes no sense why this is not faster.
So what you should see, ultimately what you should see is by virtue of extending these or increasing the number of units, this one will eventually take over.
Okay.
However, do not, under any circumstances, move to this for, like, I have 20 items that I need to sort and filter.
Yeah.
I'm going to use Transducer. No.
Okay, so, like, it's not enough that it's, like, 2 operations to move to a transducer because there's going to be some overhead. So it actually needs to be quite a bit of items and a long transformation chain.
Mm-hmm. Yeah. Otherwise, you've got all of the overhead of creating all of those functions that you are operating against, and that's not huge, but it's still necessary.
Foreplay suggests duplicate some of the map calls. We can't duplicate map calls, but we can duplicate filter calls, right?
Yep.
So let's see. And these are like. So now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 filter calls. So let's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. No, this is still slower. I think that we have some bug here. I think that we should have seen this. Either that or the also doing some optimization.
It's caching. The dragon's filter that has happened now many times is faster than it was before. Or at least
check that. Oh, yeah, it's switching between. That is so interesting. Because by all accounts, like, this seems weirdly fast to me. Because let's say if I
yeah, we're running into fake. We're running into optimized territory.
Yeah, here's the nasty thing about doing micro benchmarks and why you should never trust micro benchmarks is because the JavaScript engine does optimizations for you. Like I spent like a comment here. Should you time this instead? Let's time this and see what this gives us. 36 milliseconds. No, they seem to be similar. They are equivalent, I would say.
Which makes me feel vindicated in my optimized compose.
Yeah. Your compose was going. Yeah, but that was yeah. It's true. Dumb compose. What's the dumb compose like? Let's see, and not reverse it. Oh. Ha! Mine is no, okay. Mine was faster for a bit there, but it doesn't seem to the compose doesn't seem to affect it at all. Food Snobel says, I guess if each step in the pipeline are fully evaluating an array list rather than pulling elements by element, this will increase memory consumption, but also cache more cache misses. Not sure what he means.
Yeah, we're getting down to the RAM level, and the level.
Dear Tyrion links to a benchmark example of transducers on JS perf. Let's see if this. See, run tests.
Hooray!
Okay, so transducers are significantly faster in this case. God knows why it's not faster in our case. There's some problem with the implementation, probably.
Yeah, we'll go with that.
Yeah, either that or the JavaScript optimizer is getting lucky in this case, that our code is somehow optimizable through the V8.
But that said, when you have a large data set and you need like a seriously large data set with a lot of transforms, this is how you simplify those. This came from, I think it was mentioned in the chat, Rich Hickey, the guy behind Clojure, sort of coined the term, I believe.
Yeah, I saw his talk. His transducers talk.
And now it's hit 180 milliseconds.
Yeah, because I added a lot of items to see if it changed things.
Yeah, I think we're still hitting the cache.
Yeah.
Either way.
Foreplay asks, what if you add a side effect to the filter function like console log? Would that prevent the caching? Interesting theory. Let's see. Where's the...
that said, if you added a console log, it would destroy the terminal.
Yeah, but we didn't care about no stinking terminal. Hang on. Console.log. We're really pushing it. See what that does. Should probably make this a little bit smaller. Takes quite a bit. Wow, now it's just taking a long time to run. Oh well. Let's summarize a little bit with what we did. So we have, let's see what you have so we have a case like this. Like this is what we have without transducers. We have an array of dragons and we filter it. We have a lot of filters and maps and stuff. And if we have just maps, we can compose them easily and optimize making every function into one big ass function. But if we have a filters mixed in like this, we cannot do that. So that's where transducers comes in. And this is essentially like the equivalent what we want to do. We want to compose all of these functions where we have these uppercase transducers and stuff, and then we at the end we pass in like the array reducer. So we compose all of these things in the end. This is like the final result that we want to have, making it into one function that processes all of it. And in order to do this, we created let's remove abstractors and so in order to create something like, for instance, like the isDragon transducers that you're calling here, we have created a function called tFilter, and we're actually not. I think that we can skip that as an example and instead look at the uppercase transducer, where we jump. And let's go to the tmap, how that is implemented. What it does is that it takes the transform, which again, remember, is uppercase, and it will create a function and return that called transduce. And this transduce will take a reducer. So if we remember here that it's gonna begin by uppercase transducer here, or we actually begin with isDragon transducer, but it's gonna keep returning these transducers down. Begins with the array reducer, so it's actually going to get the uppercase transducer at the end here. Is going to get the Dragon title transducer. So the Dragon title transducer is going to get in here. So what map is going to do is that it's going to call the transform with the current item. So this is a reducer. Get the process item, pass that into the reducer that is given, like, which again is the Dragon title reducer that is being passed into this reducer. And once it's done, it's going to return. No, we're in the wrong one. Sorry. Where's tmap? God, this is so messy. We're going to return this reducer that we are. Oh wait. Yeah, we're gonna call the reducer with the target and the processed item. And since the reducer is the last reducer, that means that we are going to get another reducer out of it. So we're kind of reducing reducers. That is what that's why it's called transducers. So reduction or it's a reducer. So this is why the inception becomes this is really mind-boggling to keep in your head. It's it's very Inception-like. But the point is that this allows us to bundle all of these transformations and filters and stuff into one, which in some cases will yield better performance. Unfortunately, we didn't manage to show that in this case. Hang on. I'm trying to stop Quokka here. Stop all. Quokka start on my file. See if this gives us anything. Still think that the console log is creating way too much pressure. You are totally right to kill my console. Quokka stop all. Start on current file. 500. Is that enough? Is it still killing my console? Yeah. Wow. Okay. There you go. It's my last attempt of showing that this is faster. No, it's still showing the same problem. Who knows? Yeah, so as Simple Var points out that while what we did is theoretically less operations, the JavaScript engine is very, very smart. So it's probably like basically looking at our code, and the computer is just like, yeah, I can do this way better than these puny humans can, and it's doing like some kind of optimization. So as Simple of Ours says, optimize only after profiling. But the point being here is that in some cases where you are doing stuff like long transformations on big sets of data with long transformation chains, and you have a problem with performance in those cases, then transducers is what you need to look at.
Hooray!
Yeah. Yeah, like theorem motion says, make it work, make it fast. But I think I get what transducers are now, finally. Even though it's still a little bit hard to keep in my head, I understand, like, it's called transducers because it's reducing transducers into a reducer. Makes a lot of sense.
And on that note, I'm going to have my butter tart.
Oh, awesome! Yeah, I told Clark to definitely have a pastry, and then I don't have a pastry myself. I only have water. No. It's so sad.
Water.
All right. Thank you so much, everyone. This was one of the hardest, like the most mind-bendy and most advanced things that we have on the stream. Somebody on the chat said, "Oh, I'm just learning JavaScript. I don't know what transducers are," and I'm like, "Don't worry about it, man. It's this is a little bit down the line, I would say."
Yeah, there are people that have been doing this for a decade that don't know what transducers are, and that's fine.
Mm. Yeah, precisely. Clark AO says it was really good though. Thank you both for working through this live. Yeah, thank you so much for watching, and thank you so much for helping us out. Make sure that you follow Theory in Motion on Twitch. And if you want to see what Sean is going to be up to, I'm sure there's going to be loads of interesting content like this, and also other stuff. Maybe we'll be back and have a proper episode on monads.
Ooh.
Mm-hmm. With all that said, I think we're gonna leave it off with that.
Wonderful. Thank you for having me.
Thank you so much for watching. The sponsor of this week's episode was .tech. If you want to get a .tech domain, use the link in the episode description, because that gives you 90% off through a coupon code that will be automatically applied in the checkout. We record these shows live on twitch.tv/funfunfunction. And if you want to see more about what this show is about, you can check out this playlist over here. Or if you're already ready to subscribe, you can do so here. I am MPJ. Until next Monday morning, stay curious.